In this video presentation, we are going to discuss the correlation and simple linear regression. By definition, correlation used to determine the direction and magnitude of the linear relationship between two quantitative variables. So let's say those variables be denoted by x and y. So let's look at this figure. So you grab a scatter plot for the height and the diameter of a trunk, where the height is your x variable and the diameter is your y variable. Now, by interpreting the graph, you can see, or we can say that as the height increases, the diameter of the trunk also increases. Now, let's look at this illustration. This is the codling moths trapped per acre versus the unblemished apples, where your codling moth is your x variable and the unblemished apples are your y variable. So here we can see that as the codling moths increases, the unblemished apples are actually decreasing. Now, at this example, we can see that the scatter plot makes the interpretation for this data relatively not that easy because the data points is really scattered. So at first glance, we can actually conclude that the red clover in square meter and the pilbugs in square meter has no correlation, or there's no relationship. But however, we can actually identify the correlation. Now, to determine if two variables have linear relationship, we have to solve for its R, or the Pearson correlation. So the Pearson product moment correlation can be solved using this formula. Now, the interpretation are as follows. So if your R is from 0.9 up to 1, then it means it is very high positive correlation. If the values are negative, then it is very high negative correlation. Now, for R values from 0 to 0.3, and then it is already considered that has negligible correlation or no correlation or no linear relationship. So take note of this size of correlation and its corresponding interpretation. Now, not to be overwhelmed by the formula of the Pearson product moment correlation, you can actually solve for the R value using Excel and other statistical tool. But using the formula, you just need to get the summation of some of your data observation. So let's look at this example. So for the following data on heights and weights of 14 UAAP basketball players, determine if heights and weights are correlated. So here, we let the height of the basketball players be our variable x, and the weight of the players will be our variable y. Plotting the scatter graph, or the scatter plot of the weight and height, we have this graph. So here, we cannot actually conclude at first if if it has a correlation, or there is negligible correlation. So we have to solve for its Pearson R. So getting the sum of the height and the weight, we have the following values. Now, let's take a look at the values that we need. So first, we have the n. So n is the number of observations. So in this case, there are 14 UAAP players being considered. So n is 14. And then we need the values of x and y, or x multiplied by y. So we need to create a new column wherein we get the product of the height and the weight, and then get its sum Also, we need the values of x squared and y squared. So we need to create another columns for x squared and y squared, and then get also the sum of the values. Now, substituting the sums that we get in the formula for the Pearson moment correlation, so that will give us the computed value of R equivalent to 0.563 or 0.56. Now, to get the value of R using Excel, you can use the function Pearson, then xy or Corel xy. It will also give you the value of 0.56. So in this case, you can now get the relationship, or you can interpret the correlation between the height and the weight of the basketball players using the interpretation table that we use or that we have a while ago. Now, the simple linear regression gives us an idea or a forecast of a certain value. So to determine that, we have to first find out the equation of the best fit line or the least square error. So the equation of the best fit line follows the slope-intercept form of the equation of the line, which is y is equal to a plus bx, where b is the slope of the line and a is the y-intercept. So to solve for a and b, we have this formula. Notice that for you to be able to solve for the y-intercept or a, you have to solve first for its slope. Looking at the previous example of the 14 UAAP basketball players, determine the equation of the best fit line. So again, you need to get the sum of the x and y variable. So the equation or the line, or the best fit line of the data is illustrated in the graph. So using the values that we calculate a while ago, you can now solve for the slope by substituting the values. That is equivalent to 3.272, or by using the Excel function, you will have equal slope y and x. So after getting the slope, you can now solve for the y-intercept. So by substituting its values, you can solve for a, or the y-intercept is equivalent to negative 20.02. To get the value using Excel function, that is equal intercept y to x. Now, since we already have the values for our slope and y-intercept, we can now formulate the equation of the best fit line. So that is y equal to negative 20.02 plus 3.272x, where y is your weight in pounds and x is the height in inches. Now, what if we are asked to estimate the weight of a player with height of 71 inches? So here, we're going to use the equation of the best fit line that we generate or formulate a while ago. Now, notice that the height of equivalent to 71 inches is your x variable. So you can substitute the x variable in the equation by the given height, which is 71 inches. And we can solve for the estimated weight, that is your y value, equivalent to 212.292 pounds. And by using the Excel to generate the result, you can use the function equal forecast x, y, x, where the small x denotes the given height, which is 71 inches.